Come again.
Were you able to install the Fusion 360 software yesterday?
No, I tried it, but it didn't happen. I tried doing AutoCAD as well. It didn't come. No, that's problematic or it's not compatible or something.
Oh, okay, okay.
So
Then
I'll try doing it on someone.
okay, okay. Then right after the meeting, we can communicate behind if there is any issues that you're encountering. Just let me know so I can assist you with that.
All right.
Anyone else? Can you share with us what you learned yesterday? I can see Daniel. Daniel, you joined us yesterday. Daniel, can you share with us what you learned? Okay, it seems Daniel is not with his device at the moment. Because of time, let's wrap up so we can
Hello.
Go ahead with it. Yes,
Hello.
I can hear you.
Yeah, good afternoon.
Yeah, good afternoon, Daniel. Daniel, we are listening. Can you share with us? Hello, Daniel. Can you hear me? Okay. Okay. Daniel, because of time, let's continue with the brief of what we did yesterday, and then right after the session we can hear from you. Okay. So with yesterday's presentation, the introduction to 3D modeling, I actually got stuck for the fascinating aspect that is the applications in the oil and gas industry, where we talk about the, the digital twin design technologies, of which our speaker, Mr. Justice, did as the honors, explaining to us some future impacts of this and then what we can actually do with the digital twin design. And then the other applications as well. So let me just brush through the applications of 3D modeling in oil and gas industry. So the first one is geological modeling and reservoir simulation for exploration and production. That is in the production sector of the oil and gas industry. We use the 3D modeling to predict the structure and then also give us the real data of how the reservoir looks like for exploration and then production. And then facility design and optimization. The facility design covers with the designing of the actual equipment that we will use for the production. So with a 3D model, we're able to design so many equipment, of which saves time and also increase customer engagement and reduce cost as well. So instead of us trying to model the actual thing, we can just use the 3D modeling software to create a virtual model of what we want to have in the industry before we go ahead to create the actual equipment. And then for the health and safety training simulations, we also have this simulations where you can enter the virtual reality world to undergo some training sessions for you to be well equipped of what you need to know and then the personal protective equipment you need to wear before you can go onto the rig. So without wasting much time, and then I would give our speaker the platform for him to continue with today's presentation. Right after, we can carry on with any contributions or any questions that you have for him as well. So, Mr. Justice, can you hear me?
Yes, please. I can hear you.
Okay. Okay, so the floor is yours now.
All right, guys. Welcome back once again. And
Hello, sir. Please, it seems your voice is a bit far from the device.
please hold on. Hello. Do you hear me better now?
Yeah, slightly. We can't hear you that well.
Slightly, not very. Okay,
Yeah, it's not clear. It's not clear.
What about now? Is it better?
Yes, loud and clear.
Okay. So, thanks you for the quick recap of what we did yesterday. And hopefully today we are going to be able to take it one step further, where we will look at a brief introduction to what 3D modeling is. Today's session is going to be a brief one. And probably next week, we are going to start with the 3D modeling. So we are going to look at some concepts, some types of 3D modeling, and then when we are done, God willing, next week, we will start with the practical side of the whole thing. So today we are going to look at the introduction to 3D modeling concepts. The first part is conceptual. The second part is going to be practical, which will happen next week, Saturday. In this presentation, we are going to look at what 3D modeling is and the concepts that govern the art of 3D modeling, the types of 3D models we have, and then some 3D modeling software. And we will also look at practical introduction to 3D modeling, which will happen going next week. So can someone remind us of what we defined 3D modeling as yesterday? I'll be glad if any of the participants give us the honor of explaining in your own words, what 3D modeling is.
Hello.
Yes, hello.
Yes, hello. So for me, 3D modeling is the act of creating a three-dimensional object in a virtual field.
Daniel, is anyone willing to add anything?
This keyword.
Eugene, please, are you saying something?
Yes, okay. Look for the article that contains. Can we do these key terms? This key.
Okay,
terms.
so Daniel, thank you so much for explanation. I think he pretty much said everything about what 3D modeling is. So 3D modeling is the use of specialized computer software to create a three-dimensional representation of an object.
I go be the sugar in your cocoa, butter in your bag.
Can the host help us? So 3D modeling is simply the process of using computer to design 3D representations of objects. And it is not only an object, it could be an entire scene, like a movie or a game. Is my voice heard?
Yes, please.
Yeah.
You're allowed up.
Yes, please.
All right, thank
we
you.
can hear you.
All right, so normally we do 3D modeling. The basic fundamental elements of 3D modeling include shapes. You take a simple shape and you begin to manipulate it by controlling its vertices. Vertices are the points that join, that are formed by the edges of the edges binding the object, and you have the edges that are the lines that are connecting to form the objects, and then we have polygons too, and then we also have a 3D simulated space. And then also for 3D modeling, unlike a 2D design where you look at on top of it, it's like a plan view of something. 3D modeling offers you the variety of being able to look around it at different viewing positions from the northeast, the southeast, the bottom, and different points of views. Now, this may vary across my literature, but basically you would have a conceptualization of what you want to design. You would want to, first of all, conceptualize what you want to design. And I think this is not only applied in 3D modeling, probably in any design field, okay, where it has to do with a visual production. You want to conceptualize what you want to bring into pass, and that will serve as a guide for your work. So conceptualization is key. And then the 3D modeling design will start, okay, where sometimes you take a primitive shape. A primitive shape, consider that to be like a square, and you begin to model around it. You begin to change it. You begin to edit it in a way that will give you the desired shape you're looking for. Once the 3D model is developed, now we can use it for things like rendering. To render is like what we see in this object here. When you pass it through a rendering software to be able to see how the device will look if it is brought into real life. And then we can also simulate. I think I explained yesterday, about how you can simulate to understand how the device may work under different conditions. And that would help you form decisions about how to produce a device. We can also have animation. Animation, I think I showed yesterday, ball valve works. Okay, so you are able to create a short video of how your equipment is going to work in any of the parts of the design or the products. You should be able to animate it and let your viewer understand how the parts of the device are going to communicate with each other as they work. And we have 3D printing, like we see down here. This is supposed to be a rocket's engine, a jet engine. So they can 3D print it and then have a good idea of how it is going to look when it is brought into reality, when it is eventually produced. And then we have machine. This is a verb, and it is, I think I explained it a little bit yesterday, where I said that we have machines that use harder metals, okay, to cut through steel and other materials. So you give it the model and you give it a lump of metal, and it will cut the 3D object out of the metal. And then we also have, for visualization and analysis purposes, like if you have a reservoir, and then you want to look at where there is more water saturation, where there is more oil saturation, you are able to view and understand the various areas which has the most amount of a particular fluid. And it also helps you understand the behavior of the fluids under different reservoir conditions. Maybe when you change the pressure, or when you increase the pressure, reduce it, when you when there's an increase in temperature, how does the fluid or how do the fluids respond to these conditions? You can simulate it and visualize how it would happen, and then you can make informed decisions about the real life assets underneath. And then we also have in reservoir simulations where 3D models are used. The models autonomously is created by the software. So unlike in many 3D designing software where you have the user creating the product from scratch, okay? When you go to very typical engineering applications, normally you would just feed data into the software, and the software will use that data to generate a 3D model. That data would, of course, contain the thickness of the reservoir, the length and the breadth of the reservoir. And sometimes in the presence of many other relevant data, you are able to generate the contour. It won't look like a rectangular prism. It will look like a landmass, a chunk of a landmass that has been cut out of the earth or something. And then you are able to understand where your wells are going to produce the most and where your wells are not going to produce the most. So, but you don't design that yourself. Normally, you simply pass in the data and then produce a 3D model of the reservoir. But I think it is important to also understand how to visualize and understand and how to make decisions with 3D models. So even though you're not designing it, understanding how 3D models work will help you be able to play around different scenario production so that you can make a better decision. Now, let's look at types of 3D modeling or types of 3D models. First of all, we have polygonal models. Polygonal models, you can think of them as an interconnection of vertices in a 3D space. So you have 2D vertices connected to each other to form an enclosed object, and that forms a 3D. So you control and then you move around the edges, the vertices and the faces. You can move them, okay? And once you move it, the shape of the 3D model you are trying to create will change, and you must move it according to the shape that you want to produce out of it. So that is the first type of 3D modeling. And then these vertices are linked by the edges. And then when you have at least 3 of them, a face has been formed. And then you can control them to form your shape. And normally, in some software, especially in Fusion 360, we will be looking at it is called a mesh. It is not called it is a type of polygonal modeling, but the most popular name for it in Fusion is a mesh. So we will look at that next week when we start the practical side. And then we also have non-uniform rational B-spline into bracket NURBS modeling. Unlike polygonal modeling that uses more than three or more sided shapes, NURBS modeling normally includes only 4 shapes, 4-sided shapes like rectangles and squares. And then you are supposed to control the edges and the vertices to form the shape you're looking for. It also has a name in Fusion 360. And when we get to the practical side, we will be sure to take a very good look at it. And NURBS utilizes a network of control points that are joined together by edges to form curves and surfaces. So normally we use the NURBS modeling for extremely smooth organic surfaces. Like if you imagine a luxury car like a Lamborghini or something, you can imagine how the body is curved. Okay, that level of smoothness can be obtained using NURBS modeling. You can do the same thing with polygonal modeling, but NURBS modeling is more accurate, and it is easier to play around with when you are designing such objects. Normally, the polygonal modeling, when you don't have a lot of smoothness and a lot of curves, okay, we normally use it not to control the when we get to the fusion, I think I'll have enough visuals to explain it better. So let's just go on, please. So normally for the NURBS, we use it for very complex models. You are talking about models that are very highly organic. If I say organic, their shapes don't look like, their shapes are not well defined. You can't call them square, you can't call them rectangle, you can't call them a triangle. Their shapes are mostly organic and irregular. And that is when we use NURBS. For example, if you are designing a bicycle, okay, you may use another type of model for the other parts of the body. But when you come to a part like the seat, you see how the bicycle seat is. You have to use the NURBS, okay, because it gives you a lot of liberty to manipulate almost every part of the model, so that you can really produce what's the shape that you want to produce. I want to, please permit me to show you using please give me a minute. Let me bring up a design. Please spare me a few minutes. I'm trying to bring it up here. All right, so when it's ready, I'll bring it up so that we can see what I'm trying to talk about. And then we have the parametric or the solid modeling. The solid modeling is probably the easiest to learn. And as beginners, I think that would be the most ideal environment to find ourselves in. So it's up here. Let me, please, can you confirm for me if you see the screen?
Yes, sir, I can see.
Okay.
Yes, please, we can see.
Thank you. Please. A minute. My laptop is acting up a little bit today. Quite unexpected. We'll be here shortly. Oh, God. So I don't know if you can see my screen here.
Yes, sir, we can see.
I'm expecting you to see a bicycle or something like a BMX bicycle.
Yeah, that's it.
Yeah, so this is one of my designs I produced a couple of years ago, and I wanted to explain the difference between the solid modeling and the NURBS modeling. So I don't know if you see it very well, but when you look at the bicycle, when you look at the seats, you realize that it is more organic than the, sorry, it is more organic than the, it is more organic than the other parts of the bicycle. Organic means that its shape cannot be defined by a particular primitive shape, like a square, a cylinder, a triangle, a circle, or something. So the difference between the solid modeling and the parametric modeling is that it gives you the parametric, the NURBS modeling or the surface modeling gives you the ability to create new irregular shapes. Okay, so you practically take a sheet and then you bend it and model it in a particular way to produce a new shape. However, for the solid modeling, you only take like definite shapes like circles, rectangles, squares, and then you manipulate them to create other shapes. But you realize that even after creating the new shape, you can see traits of the primitive shapes in it. So for example, when you look at the handle of the bicycle here, you can tell that it is comprised of a series of cylindrical shapes that have been joined. When you look at the body over here, the frame, it is also cylindrical. But when you look at the tie, it looks like a circle. Okay. But when you come to the seats, it is very difficult for you to describe. And that is what I mean by organic. Okay. All right. So the solid modeling is probably the easiest to learn, because with that one, you are able to use shapes that you are very familiar with, and you are able to manipulate it. You are able to cut through it. You are able to extrude it. You are able to join. You are able to sweep around it and do a lot of stuff that would make it easy for you to learn. So, God willing, next week, we are going to start with that type of modeling, and that is what is going to usher us into the 3D world. All you should know is that for the solid modeling, you are looking at, it is used to represent volumes that are real. So what I mean by that is that it has a mass, it has volumes that represent matter. So it has a mass, it has a volume, okay? So once you design in Fusion 360, you are able to tell, based on the material you're using to design, it is able to calculate based on the size, how much density it has, how much volume it has created. So solid models are called solid because they are normally enclosed. They are like the tangible type of drawings. But for the NURBS and those kind of drawings, they don't have a thickness. Until you give them a thickness, they don't have one. They are like an infinitely thin amount of sheets, and then you are just controlling it, okay? But for the solid, it is enclosed and it has a definite volume because it has a definite size, okay? And they are normally constructed using primitive and definitive geometric shapes like cubes, spheres, cylinders, and cones, as I explained earlier. And solid models employ Boolean operations like union. Union means combining them. Intersection means cutting through one body and then to create another one. And then subtraction means cutting through one body by another body or a sketch or something. So using this and a series of other processes, we are able to create other complex shapes out of the ones that we originally started with. So unlike this, the image we see here, it is a ridiculously simple design. But when you go up here and then you look, it becomes more intricate. But it will surprise you to believe that all of these shapes here are formed from definite shapes. They are like they probably started from a square, a rectangle, a sphere, and they modeled from there. For we normally employ solid modeling in highly mechanical products. You are designing a motor engine, you are designing a valve, you are designing something that is mechanically intensive. You would want to use solid modeling because mechanics also requires very specific dimensioning. Okay, so if you are using like a NURBS model like this, it doesn't have definite shapes and definite parts. So it is very difficult for you to mechanize them. But if you are using solid modeling, it's very easy for you to do animations, and then especially in product design and architecture. The last type of 3D modeling, which is like an entire world on its own, is digital sculpting. Digital sculpting has to do with using digital clay. So it's basically like a potter without a physical clay, but a digital one. And normally it is used by artists, like 3D artists and animators, those who create movies and animate animation videos and all of that. So they use it to create highly intricate parts, like normally human and animal. Okay, normally human and animal figures. Okay, so that one, it is normally used by artists, and it applies a lot of art theories and all of that. It is not usually mechanical. It is mostly artistic. And then you need to be able to work with those art concepts before you can create a very appealing masterpiece. So you have something like a clay, and then you can use your digital pen, your pen, to, you know, on the screen of the device you are using, you just move it around and it will be forming the shape you want to create. Now, to end it all, I would like to introduce us to a number of 3D modeling software, and that'll be it for today. We are looking at Blender. Blender, I think, is a very popular tool. Even if you don't use it personally, I'm sure you may have heard of it. It is normally used for animations. So where can we apply it in the oil and gas industry? We can use it for visualization of oil rig structures. If you want to create a video showing how the rig works, you can use Blender. It gives you some ability to create mechanical components, so it shouldn't be a problem. However, Blender is extremely powerful that we can use it to create both animations like movies and games and videos. And then you can also use it to create mechanical structures as well. I think it is very light. So learning how to use Blender is ultimately a very good choice. And then you have equipment design, of course. You can also use it to simulate fluid dynamics, how fluids flow through pipes and the behavior they undergo under different conditions. You can simulate all of those things. And we also have Autodesk Maya. Autodesk Maya is from Autodesk. And it is chiefly used for animation. You can use it for animation for training videos, animation of training videos and simulations. If you can't afford a VR or an AR, and you have a good 3D animator who is versed in this software, you are able to bring to life many of the training simulations that you want your team to learn. And then you can also use it for visualizing of many different other processes, rigging for mechanical components as well. You can also do it. Then we have 3D Max. 3D Max from Autodesk, plant design. I spoke of it yesterday when we looked at you are talking about the various purification stages that produced oil goes through. You can use 3D Max to also visualize that process. You can also use it for pipeline layouts as well. And then we have Cinema 4D. Cinema 4D is also an extremely powerful tool. I think it is open source. Normally, the Autodesk software are not open source, but Blender is open source. Cinema 4D is also, I think, is also open source. But it is also a very powerful tool like Blender. You can do several types of animations with it. Offshore platforms, product animation like the one we saw yesterday from Baker Hughes, and motion graphics for presentation videos. And then we have the one we are going to use in the next few weeks, Autodesk Fusion 360. You can use Fusion 360 for equipment design and manufacture, like a drill bit, like a plant, like a valve, like a pump or something. So if you have a new idea of a pump you want to design, or a service company wants to pitch a new equipment to a client, one of the software they can use is Autodesk Fusion 360. It offers you a lot of mechanical abilities to be able to illustrate all your processes that your products are going to go through. And it is a very powerful tool. The interface is pretty much simple. Those who were able to install it yesterday may have had a feel of it. It is very simple. You can also use it for pipeline design. Then we can also use it for simulation and analysis. There is a part in Autodesk Fusion where you can simulate how a device is going to respond to different functionalities. We will look at that next week when we start designing. And then we have Autodesk Plant 3D. This is the one you want to use when you are doing plants, typical, very highly intensive plant design. That one, it is dedicated for plant design and piping and instrumentation diagrams in 3D. And then we also have like how flow processes, pumps. And for Autodesk plants, when I got to use it, what I learned is that you don't create the 3D models yourself. Unlike in Fusion, where you have to create every valve. So normally the Fusion is used for specific products, okay? You can also use it for plants and piping documentation, but the thing is that it means you're going to have to design every single project, every single piece, or you can just design from other pieces and then edit them, but that's going to be a lot of work. So the most suitable software to use for plants 3D is Autodesk Plants, okay? Because the pipe, you just select the options, it will bring up the pipe for you. You just select which pump, centrifugal, or whatever pump you want to use. You just select it and it will bring it. And then you will just join it to a pipe. If you want to use a butterfly valve, a ball valve, a one-way valve, or a four-way valve or something, you just select it and then you specify it will introduce it into the model, and then you just position it, right? And then we have SolidWorks. SolidWorks is more of like Autodesk. It is a competitor for Autodesk Fusion because it is also used for mechanical design a lot, but it also offers you the ability to do piping and instrumentation and documentation design.
Please, please, I have a question.
All right, please go on.
Okay, please, after that, will you show us how to use the software, like for designing and those things?
Yeah, so we are going to learn how to use Autodesk, but that's going to be next week, God willing. That's when we start the practical side. Hello?
Please. Thank you very much.
Please,
Yeah.
did you get my answer?
Yes, please. Yes, please.
Okay. We hope you are fine
Thank you
with
very
that.
much.
So when we start the 3D modeling, it is pure 3D modeling. We're not going to do it anymore. But I think understanding the theory is really important. That is why I'm taking the time to take us to. But from next week, we are going to start intensive design, and that will be very fun. So the last one is SolidWorks, also like 3D, Autodesk Fusion 360. You have many more like Autodesk Inventor. Autodesk Inventor normally combines AutoCAD and 360. And then we have FreeCAD and many more. So that is it for today. And I don't know if I I should send those of you who are struggling to find install the software. Can I know the challenges or whatever error message you received? Hopefully I can help you so that as you go, you'll be able to install it.
Okay, please, can you send us like any link for us to like download it?
The last slide.
No, I mean the software.
The one we used yesterday, right?
Yeah. But like yesterday, I couldn't join the class because of some issue.
Yes,
So please, he's asking if you can get the link to download the Autodesk Fusion.
So you simply go to, you can use the link to go to the Autodesk website. And when you go to register. Okay, or I think, but you will need to create an Autodesk account first. So use this link to create the Autodesk account. And then you would use this link to access the Fusion 360 parts of their websites where you have access to the free trial. You will be made to log in with your new account, and then you will be made to download the software. The software is 13 megabytes. So, but it has to install it from the cloud. There is no cracked version. So it has to install it from the cloud. So once you download the setup, it is 13 megabytes. Once you run it, you will need a very good internet connection, and then it will download it after about, depending on the resources of your device. And normally you would need like a minimum of 8 gigabytes RAM. And also an i5 shouldn't be a big deal. i5 and above shouldn't be a big deal. Even i3 you can do something with i3, but you know, the higher the processor, the better the experience. It is a graphic intensive software. However, you are able to find your way around it using enough RAM and a good processor. And then you would also need an SSD, not an HDD. It will work on an HDD, but it will be slower, or it will be faster on an SSD than on an HDD. And I think if you also have a very good display, like 1080 by 1080.
Hello.
Yeah, hello.
Yeah, please. The link you are saying, I can't find the link.
The link is in the charts. I think Adolf copied and pasted it here.
Okay. Thank you very much.
You're welcome. So once you're able to do that, you should be able to access the software. And I mean, once you are able to download it, I think you should feel free to, how do you call it? Just be playing around it and be making a lot of mistakes. Feel free to use the Control-Z button and just get yourself a little familiar. But God willing, next week Thursday, and sorry, next week Saturday, we are going to enter into a very intensive level of design, and I'm sure you're going to enjoy it. Right, I've pasted we've sent the link again to the chats. Adolf and I have sent it, so. Okay, so thank you very much for today, and I appreciate the time. Thank you to SP Ghana too for the opportunity, and I hope that next week we are going to be able to return here and then start with the practical side. But I was wondering if I could send a little survey, you know, as a way of improving upon, as a way of getting feedback, and then how to improve the future lectures. So I'll be glad if I don't know if it is possible for SP to take it up, if it is possible to take it up so that.
Yes, it's possible, sir.
Yeah. I'll be very glad if I can get a quick feedback on how the lessons are going, and we can find a way of improving it if there is a need.
Yeah, we'll reach out to you right after the meeting, and then we'll get that for you. So thank you too for joining us today, Mr. Justice.
You're welcome.
And having the discussions on the 3D modeling has been very insightful. And those of us who also joined us today, I hope you also found today's webinar very informative and engaging. I'm seeing someone has a question. Mohammed, please, you can unmute yourself and talk.
Yeah, thank you for the opportunity. I want to find out if it's possible that we can get the slides for possibly future reference.
Slides.
The one the moderator is using.
You mean the presentation?
The presentation.
All right. I'll send that to Odame, and then I'll send it to Ajapon and Odame so that you guys can access.
Oh, okay. Grateful.
Or should I send it here, or I can send it to you and you guys will forward it to them?
I think if you forward to them and they put it on the page, it will be better.
All right, that's fine.
All right, thank you.
Okay, so Ms. Frimpong is also asking a question. Yes. Frimpong, the videos of these meetings will be uploaded to SP Ghana's YouTube channel. So once you're part of the capacity building group, the links will be posted there, and then you can access the videos using that link. Any other questions? Okay, Wisdom. Please let me send a link to the capacity building platform, WhatsApp platform, so you can join the link right away, and then whatever information we can share it on that platform. Please, any other questions?
Adolf's hand is up.
Yeah, Adolf.
Yeah, Justice, I want to thank you again for such an amazing session we've had today. I mean, we are learning a lot. My question, you may have touched on that though, so pardon me for asking again, but I would want to find out in terms of reservoir simulation, which type of 3D modeling is used there? Is it a polygonal, the NURBS, or SolidWorks? Solid modeling. Yeah.
So I think for the ones I have experienced, I would say it is not revealed which particular one it is. Normally, the types of 3D modeling we looked at here are the ones that you have control over, right? The ones that allows you to interact with it directly and edit it and modify it with your computer. Because for the reservoir modeling ones, you don't have direct access to the model. You don't edit it, you don't adjust it, you don't do anything. You only input in the value and then it generates the model for you. So even though you have ability to visualize and view it, it doesn't give you the freedom to be able to like edit it. So I think the reason why I brought up the various types is for editorial purposes. The ability to edit it and understanding how they are formed gives you an idea of how to go about them. But I think I have seen reservoir models that use the polygonal modeling as their look. Some of them look like a polygonal model. So when you see polygons connected to each other like that, I think it is polygonal model. One I have seen before. it is polygonal model. But there is one too in Petrel by SLB. I think we had access to it in school. I think Petrel or Eclipse, one of them. That one, it uses solid modeling because it represents the reservoir simply as an amalgamation of like rectangles and squares. Okay, so I think some use polygonal models and some also use solid models. Okay, so it depends on them, but so far the ones I have seen, it is only polygonal and solid.
All right. Thank you so much, Justice.
Yo.
Fantastic. Please, I also have a question.
Okay.
So talking of the types of 3D modeling, you mentioned digital sculpting.
Yes.
Can we also use Fusion 360 to do digital sculpting?
So Fusion 360 can give you, for example, there is an environment, a workspace, or an environment in Fusion 360 where you call it form. Okay, so it is basically like you take a body and then you draw. So I think, let me just be straightforward. You don't do, there is nothing like digital sculpting in Fusion 360, but there is a way of working around it, just that it's a little bit more challenging than if you were having a digital sculpting environment. But some we have how do you call it? The NURBS in 360, which you can use to, if you are very good at it, you are able to manipulate it to form like bodies that you could actually form using digital sculpting. So yeah, I don't know if that answers it, but there is nothing like digital sculpting in Fusion 360, but there's a way of working around it if you want to create a very realistic art, but it's not for arts and stuff.
Okay, I get it now. Thank you so much.
You're welcome. So I don't know if I can have like 5 minutes to the app is working now, is up now. So if you can spare me like 2-3 minutes, I wanted to
yes, sure.
Yeah, clarify one thing. Yeah. Yes, so this is the a spherical body here. So this is the NURBS. So like you see how smooth it is. So it has an interconnection of all of these things, and you can pick a vertex and then you just manipulate it. You can pick a face, just drag it out. You can also pick and drag it like so. That is how the NURBS work. So you have rectangles, approximate rectangles, four-sided rectangles, and then you are working with them. But the solid is more like this. So this is called form in Fusion 360. It is called a form in Fusion 360. And as you master the various areas of Fusion 360, I'm sure you can come across it. There may be different names given to it in other software, but they all apply the same principle. So if you are very good at it, you can use this to model a face. Yes, that is going to be highly intricate, but you just have to add more rectangles and you're going to be able to do something. And then we also have the solid, the one I was talking about. Let me show the mesh. This one is what uses this. Well, let me go to solid first. So for solid, for example, as I said, you can form it from like you can create like primitive shapes, like a square. You can create a simple square like this. You specify the dimensions and then the heights. So from here, you can do other modelings you want to do to it. So you realize that it is enclosed, okay? So it is enclosed, it has a volume, a measurable amount of volume. And then you can either create a hole through it. Sorry. You can create a hole through it. You can also create a sketch. So that is a solid modeling. Okay, so you simply have a body you start working with, but you can't drag the vertices like you can do to this one. And then we have the mesh. The mesh is something like this. Okay, normally it is more complicated than this, but normally we have a mesh. It looks like this. Then as you can see, you have the three-sided, three-sided polygons, a triangle over here, and then you start working with them. It is more advanced. It is a more advanced version of 3D modeling, which we would not touch on in our 1-month webinars, but I'm sure that as you advance in your career in 3D modeling, you can tackle them. So, and then we also have a surface, okay? But I think I'll save the best for later. God willing, next week when we start, we should be able to cover all of these things. But I hope at least by this, you understand the differences between the types of 3D models that we have. So thank you very much for the extra time.
Once again, I want to personally thank you, Mr. Justice, for your time and expertise.
Thank you very much. Thank you.
You're welcome.
Okay.
Do you have any questions or contributions? Okay, so to all our participants, thank you for joining us today. And you're looking forward to seeing you at our next webinar. That is next week. And then for those of us who joined us today, and then if you're not part of the capacity building team, I've posted a link in the chat box. You can join the WhatsApp platform and then you can continue from there. Please make sure you utilize the link to install the Efficient 360 software before we meet next week. And at this point, if there's no other question, I think you can call it a day.
All right, thank you, everyone.